everyone, and welcome to the Be Inspired series. My name is Julia Hoggett. I'm the CEO of the London Stock Exchange. Now, there are some great companies to celebrate in the UK, and we've had the absolute pleasure in this series of already celebrating a number of them. I'm utterly delighted to be joined by Andy Osmant, who's the CEO of Cambridge Mechatronics, to talk through what the company is doing and its vision for the future. Welcome to the London Stock Exchange, Andy. It's lovely to have you.
Thank you, Julia. Thank you. Very nice to meet you.
Now, Mechatronics, that's a big name already, and a lot of kind of what that means will go over people's heads. It certainly went over mine until I read the briefings for this. Yes. But can we explain a little bit about what the technology is and what Cambridge Mechatronics does, and a bit of its application, and then we can explore a bit more about the company?
Yeah, sure. Well, let me just explain the name first of all, and then I'll tell you what we do. So, Cambridge, we like the Cambridge brand. It's a good brand. It's recognised all over the world. We operate all over the world. Mechatronics is a reflection of our mix of engineering skills. So we have mechanical engineers, and we have electronics engineers, and we bring it all together in one name, so Cambridge Mechatronics. So in terms of what we do, we are we're the world leader in designing and controlling SMA actuators, and that will mean probably next to nothing to you.
I was going to say there's an acronym and a word that we think we might need to unpack.
Yeah, so let's start with SMA. So SMA stands for shape memory alloy. So it's a metal alloy. We use it in the form of a wire, and we use it to actuate things or to move things. So actuators are miniature motors, little devices that move other things. So our primary application, or the main application that we've really invested engineering in, is in the field of smartphone cameras. So we use the wire, the SMA wire, to actuate or to move the lens or the image sensor in the smartphone cameras. So we attach the wire to the lens or the image sensor, and we can then move it. And so we can focus the camera by moving the lens in and out, and we can also deliver what we call OIS, or optical image stabilization, which to the layperson is anti-shake, to take shake and blur out of pictures and videos. So we're improving the quality of smartphone cameras by using our SMA shape memory alloy technology.
So is that one of the reasons why I could take better photos on my phone of the Northern Lights recently?
I would absolutely expect that, Julia. I'm sure that's... but you know, the camera in a smartphone... In fact, there are multiple cameras in smartphones, generally 4 or 5 in every smartphone. And it's a big marketing tool for the smartphone makers. TikTok and social media, there's such a lot of video sharing and photo sharing. The camera has become a really key, integral part of the smartphone. So, so we have a very big market. The smartphone market is 1.2 billion units a year, and the smartphone camera market is 5 billion units a year.
And that's never going to get disaggregated now, is it? People are just used to having that sort of capability in their pocket the whole time.
That's right, and people want better and better quality cameras. So the smartphone has become the new digital stills camera. People very rarely these days carry a digital stills camera. You carry your smartphone and take your photos from that. But our technology, actually we have a platform technology with many potential applications for the technology. Learning how to control this wire, which is very hard to control. People have tried, many companies, big companies have tried to control SMA before. And it's really our team of clever Cambridge scientists that have worked out how to very precisely control SMA, and that's opened up a huge range of new potential applications for the technology.
So let's explore that a bit. Can I explore two things? One is, people have probably got a vision. I mean, when I first thought about it, I had this vision almost of a wire that you could see that was sort of moving things around. But these are very minute. Very minute
devices. So the wire that we use is thinner than a human hair. It's almost invisible to the naked eye. So, you know, we use a 25 micron wire. It's incredibly thin, takes up very little space. And, you know, that means that in certain environments, such as the smartphone environment, where space is really precious, and, you know, people are trying to cram in as many different components in a very small available space, And having such a miniature, tiny actuator is particularly useful in that environment.
This is one of the things I'm fascinated by. The more advanced manufacturing companies I go and visit, you think about sort of manufacturing and you think about product and warehouses and these forklift trucks carrying product around. Yeah. And you get to businesses like yours and you can fit the product on a table.
Yes.
And that's a large order.
Yeah, we can get a lot of cameras
I was going to say,
on the table. Yeah.
So in terms of the sensitivity of this product, and do you make the SMA device and then fit it into a particular kind of package or unit, or are you shipping out?
In fact, actually, our business model has changed over the last 18 months because up until about 18 months ago, we were a pure licensing business.
Right.
So we took license fees and royalties and engineering fees. And actually, we formed the view that we weren't extracting as much value as we deserved from that particular business model. And so what we've done is we've developed our own chips to sell to the market. And our clever control algorithms, the software sits on the chips. So now the business model is that we still license. We license our designs. We have 800 patents granted and pending.
That's huge.
So it's a big portfolio. We think it's almost impossible for anyone else to work in smartphone cameras, at least, with SMA without infringing our IP.
Right.
And we license that technology, and we license it to manufacturing companies in China and in Korea and all over the world to allow them to make these miniature actuators. Those actuators then sold onto the camera module maker. The camera module maker then buys our chip, which controls the SMA wire.
I see, right.
And assembles the camera, and then the camera itself is sold into the smartphone maker.
Right. So you almost get at it from several angles in that regard.
We get a revenue flow from the patents, the mechanical patents, from the actuator maker, and we get a revenue flow from the chips that we sell. That hold the other part of our IP, which is our control knowledge.
And we're starting to talk about uses. We talk about camera phones.
Yes.
And so, obviously, there's probably two major manufacturers now who dominate the smartphone market.
Yes.
But you've got billions of units every year that you could be in.
Yes, correct.
How do you, and lots of different applications, how do you think about the balance of scaling for you between the capacity to feed the markets that you're already into versus kind of being able to accelerate into other markets as well?
Yeah, in the smartphone world, the supply chains that we use for the different customers are different. Yep. So in China, we've shipped in just about all of the major Chinese handset companies, and we have separate Chinese supply chains.
Right.
In Korea, you refer to the Korean and the American company.
Yep.
They have their own dedicated supply chains.
Yep.
There's some overlap, but largely they're separate supply chains. So for us to really penetrate the smartphone market in the way that we think the technology should be able to penetrate, we need to be able to work with those different supply chains across geographies.
So you're having to operate across several strata.
Exactly.
And does that mean lots of different relationships to manage?
Lots of different relationships to manage, lots of involvement throughout the entire process, from the actuator maker making the actuators through to the smartphone maker.
Yep.
Delivering the smartphone. So we're involved throughout the process, lots of relationships. And it means we have our own teams in the different locations as well. Right. So we have a big team in China, for example.
Yep. So moving on to the other use cases.
Other uses. As I said, they're almost countless. And so the big kind of challenge for us as a business is to invest in the right areas, not to try and spread ourselves too thin.
Yeah. Because you could do almost anything.
We could do almost anything. Yeah. We could do almost anything. We're only 130 people, so it's a small company in terms of manpower. So the areas that we're really interested in, and we think there's really good opportunity in the short to medium term, are in medical devices. So we're developing miniature pumps for pumping medicines in the body, and in particular a miniature insulin pump. And that's an interesting market and opportunity because next generation. Well, first of all, people wear these little pumps on their body, and so you want them to be as small as possible and as lightweight as possible. And obviously, our technology, because it's just a wire, it's very tiny. So it means it's very small. So it means that there's more space in the pump. So you can either have a smaller pump, or you could have the same size pump, and it would last many days longer than it does at the moment. So both of which are obviously good for the people that are wearing them. And the other big development in this world is people are developing next generation insulin, which is far more concentrated.
Right.
And again, it saves a lot of space within the device. But
you've got to calibrate delivery much more as a consequence.
You've got to calibrate delivery. So the delivery becomes much more complicated, much more difficult. And our technology is incredibly precise. The control is incredibly precise. Sub-micron control capability. So the combination of the small size and the very precise control makes it, we think, a really good match for this particular market and application. And so we're working with a number of huge medical device companies on that. That's a bit longer term than the smartphone opportunity, which is here and now.
But it illustrates the breadth of what those opportunities are.
And then we have many others that we could be working on. We are working in the AR, VR glasses space because there are many potential applications in glasses and AR glasses and VR devices for actuators.
I'm looking forward to the day when I can tell people that, yes, I'm old school and I've been wearing glasses forever, rather than just because we're now all just seeing them in front of our face with virtual reality.
Exactly, well, me too.
Now, you talked at the very beginning about the Cambridge name.
Yes.
And obviously everything you've already described is an illustration of the very high tech, but the constant evolution as well of the potential for this technology. And I always describe the UK as having a huge number of those really hard to get kind of attributes. It's got remarkable research coming out of universities. Actually, our spin-out rate is now very high, and some of it's better than in the US in terms of dollars spent to produce outcomes. We've got a world-leading capital market by any measure. Our trick actually is to make sure they're properly connected together. I'd love your reflections on being part of that Cambridge ecosystem in terms of what it's done for the company, but also what it might do for the future, and any reflections on that, bringing that ecosystem together point.
Well, I think for us, we couldn't have done what we've done without being in Cambridge. Maybe we could have done it in Oxford. I don't know, but we're very. We have a lot of connections to the university. Our founder was a Cambridge academic. I would say a big percentage of our staff have been through Cambridge. They're Cambridge graduates. In terms of our funding, actually, our funding was originally derived from Cambridge and Cambridge Angels.
Right, yep.
There's a lot of angels in Cambridge because actually a lot of entrepreneurs, having had some success, want to continue to give back and invest in technologies that they're interested in, and the value there is not just the money, but also the mentoring, because they've been through a similar process as the one we're going through. We were funded for many years by a network of Cambridge Angels, which then turned into a network of London angels and investment bankers, and really for 20 years we were funded in that way. We steered away from venture capital markets and other sources of funding for many years. We had one particular investor, a guy called Stuart Newton, who was the founder of Newton Asset Management. And he has been incredibly supportive and invested for many years in the business, and brought with him an
ecosystem.
An ecosystem, more recently, just last year, in fact, we closed a big venture capital round. There we had to hunt a bit wider, not just wider than Cambridge, but actually wider than the UK. I'm very pleased that we brought in some tier one VCs in the last year. And got Intel and Sony Ventures and Atlantic Bridge, Supernova. So we've got a set of really good VCs.
And also institutions that are endorsing the very technology that you're driving as well.
They're endorsing the technology. In the case of Sony is arguably the dominant player in smartphone cameras,
Yeah.
because they supply, a very significant percentage of the world's image sensors, one of the key components in the cameras. And, I think their investment is really forward-looking and seeing where that market is developing, and seeing that with bigger image sensors and bigger lenses, you're going to need different sorts of actuators to move those in the future. And our technology has something like 10 times the force of the competing technology.
Right.
So in
So
this
it can
world
scale.
where image sensors are getting bigger, lenses are getting bigger, you've got more force needed to lift and move those. That's a great direction for our technology.
Yep. So where do you think the future lies? You've obviously had this investment, and that's taking you on the next stage of your journey. So what's your sense of how the next 5 years or so will go?
Yeah, so the big change for us, as I described, was this move in business model from licensing to becoming a semiconductor selling company, a fabless semiconductor company. And that change has meant that we've had to bring in new skills, new people, new engineering backgrounds. But the ambition for the company is, first of all, in smartphone cameras, you mentioned the size of the market; it's enormous, and we're just at the edge of it at the moment. So, we believe that we could and should be able to ship into all of the handset companies that we've mentioned. And in high volume. And so we want to really take a much bigger piece of that smartphone camera market and sell our chips. Because that's actually quite transformational financially. We take something like 6 times the revenue that we did under the licensing business model, just by being able to sell the chip as well. So we want to really create a much bigger role in the smartphone camera world. And then we want to develop some of these new applications and take them into market with partner companies. I mentioned the insulin pump and the AR, VR. Imagine autofocusing glasses where you don't have to go to the optician. You don't need
the multiple versions of varifocals that these are at the moment. Yes.
How do you do that? You do with actuators. So there are just so many different applications, and we want to develop a number of those in addition to the smartphone camera opportunity. And we want to become profitable, we want to become cash generative, and our view is once you've achieved that, then it opens up options. And we're here in the London Stock Exchange, and IPO becomes an option once you're in that position. So we've got some steps to go to get there, but that's the ambition.
Yeah, and look, I think you're exactly the illustration of the thing when I get the opportunity as a platform to talk about is these wonderful things that we develop in the UK, sort of world-leading science that we should be so proud of. And the opportunity to scale it and grow it and keep it as a great British, both innovation and champion, I think is something that we should all aspire to.
Absolutely.
Now, one final question, a slightly personal one. The more you talk about this and the more I hear this, it's fascinating. And the opportunities are huge, from insulin pumps to phones or whatever. Is it exciting for you as a journey to go on?
It is exciting. It's a long journey. I've been in this company for over 20 years, which just I can't believe. Crikey, I can't believe it's been that long. But it has been that long. But it's exciting. We enjoy the journey, and from a personal perspective, it's good.
Well, I have to say it's shown. And I think it's a remarkable story. I think an illustration of what we can do in this country and what is already being done, the great ecosystems we're creating. So thank you also for having come into the exchange today, but also for everything you've done over the last 20 years to create this company and do this. It's remarkable stuff. And it's been a real pleasure. Thank you.
My pleasure. Thank you.